Our objective today is to write a quadratic in standard form to vertex form and the reverse. We're going to have it in vertex form and we're going to write it in standard form. And we're going to do that by completing the square. Then we're also going to extend the lesson by solving by completing the square. So we're going to solve by completing the square, and then we're going to go from standard form to vertex form using the complete the square method. So in our first problem, it says change the quadratic from standard form into vertex form using complete the square. That's what I'm going to do over here. It says then solve it. So that's what I'm going to do on this side. And when I solve, the x values are your x-intercepts if I were to graph this function. All right, so if you have your graphing calculator handy, go ahead and take that out because I'm going to show you kind of briefly what we can do to solve. So let's start out with standard form to vertex form. If you remember, if this is my original problem and I have standard form to go to vertex form, the first thing I want to do is move over my constant. So I'm going to work over here. I'm going to say y minus 11. I'm going to subtract over 11 is x squared minus 8x. All right. I'm trying to create a perfect square trinomial out of 8x squared minus 8x. To do that, I take half my b value, I put plus a blank, and my magic number is going to be my half of b value, so my b over 2 squared. So if I add 16 on the right side, I have to add 16 on the left side in order to balance my equation. So let's clean it up. 16 minus 11 is 5 plus y. When I factor this perfect square trinomial, it will be x minus 4 quantity squared. And if I were to solve for y by moving the 5 over, I would have to subtract the 5 to the other side. So I've just successfully changed my equation from standard form to vertex form. If you remember from vertex form, my vertex of my parabola is opposite what's in the parentheses, the same as what's outside the parentheses. All right, so that would be the vertex of my graph. I'm going to go ahead and go to the solving part. When I solve, I'm going to go ahead and solve from this vertex form, meaning I'm going to take y equals x minus 4 quantity squared minus 5. And I want to solve that. In order to solve that, I'm going to have to set my y value equal to 0. So every time where you're solving, the first thing you want to do is set your equation equal to 0. All right, so I'm going to start out by setting it equal to 0. And when I solve, I'm solving for x. So I want to isolate the x. So I'm going to add 5 to the other side. And now again, if I'm isolating x, if it's something squared, I have to square root both sides. But be careful, when you square root, we're going to have plus and minus solutions. So I'm going to have plus or minus root 5 is equal to my square root squared would just go away, so I have x minus 4. If I'm solving for x, I'm going to add 4 to the other side, so I'm going to say 4 plus or minus root 5. So those would be the two x-intercepts of my graph. Now if you take your calculator and you go ahead and plug in 4 plus root 5, okay, 4 plus root 5 is going to get you 6.24. And take a second on your calculator and do 4 minus root 5, and that's going to give you 1.76. What these two decimal equivalents of this radical, they stand for what my x-intercepts are if I were to graph this quadratic function, meaning I would hit at 1, 2, 3, 4, 5, 6, like 6.24, and I would hit at 1.76. Now, I know my vertex too, which is nice because I have it in vertex form. It's going to be 4, negative 5. And this should be a smiley because I have a positive x squared value. So my graph would look something like this. And this is just an extension, but it's trying to show you, hey, when I change from standard to vertex, I can easily find my vertex, and I can also solve to get my y-intercepts. So these are my two x-intercepts. My vertex here would be 4, negative 5, and that would be the sketch of my graph. All right, let's do the same thing on number 2. I have x squared minus 5x plus 2. So let's take this equation. The first thing I'm going to do is subtract the 2 over to the other side so I can change my standard form to vertex form by completing the square. So subtract 2, x squared minus 5x. When I go to take half of negative 5, just leave it as a fraction. It's negative 5 halves. Again, dividing by 2 is the same thing as multiplying by a half. I'm going to put plus whatever this number is squared. So whatever my b over 2 is, if I square it, I get 25/4. But if I add 24 on the right side, I don't know why it's going away, I have to add 25/4 on the left side. So what makes this a little more challenging is that I'm going to have to find a common denominator. So I'm going to say y, I have 25 over 4. This is 2 over 1. So let me make that denominator 4. So if I multiply the bottom by 4, I multiply the top by 4, and I would get 8/4. On the right side, if I clean it up, again, this is going to be a perfect square trinomial. The x minus 5/2 would be what goes in my binomial squared. I've got to simplify this, so y plus 17 over 4 equals x minus 5/2 quantity squared. And again, my final answer, I want to get y by itself. So I'm going to say y equals x minus 5/2 squared, and then subtract the 17 over 4 over. So now my equation is in vertex form. My vertex would be positive 5/2. Remember, it's opposite what's in the parentheses, and then the same as what's outside the parentheses. Okay, so if I were to just kind of sketch this, 5/2 is about 2.5, and negative 17/4 would be 3, 4, between -4 and -5. So I know my vertex is around here. All right. Sorry, I don't know what I'm doing. 0. Let's go ahead and find out where the rest of my graph looks like by finding the x-intercepts. The way I find the x-intercepts is taking what I just got in vertex form, and I'm going to solve it. So what I'm going to do, when I told you before to solve, we have to take the equation we just found and set it equal to 0. So I'm going to say x minus 5/2, that quantity squared, minus 17 over 4 equals 0. You're solving for x, so isolate the x by getting rid of the 17/4. So I'm going to add over 17/4. If it's something squared, I square root both sides to get rid of the square root. So I have x minus 5/2. Don't forget your plus or minus. Now, if I do square root of 17 over square root of 4, I don't know what the square root of 17 is, but I do know the square root of 4 is just 2. So I can kind of simplify it as plus or minus root 17 over 2. If I were to add 5/2 over here, I'm going to have 5/2 plus or minus root 17 over 2. Because these both have the same denominator, you could clean up that answer and say 5 plus or minus root 17 all over 2. So those would be the two x-intercepts. Those would be the solutions of that equation working from vertex form. If I use my calculator and I find out 5 plus root 17, press enter, divided by 2, you're going to get 4.79. So make sure you try that with your calculator just to double check that you can get something from radical form into decimal form. If I do 5 minus root 17 over 2, I get 0.208. And these, again, symbolize where I'm going to cross my x-axis. So if I went to about 4.79 and 0.208, my graph, and again, I'm just sketching, but my graph would look something like this. From using my vertex and using my x-intercepts, I was able to sketch my graph. Okay, let's look at number 3. Now I have a coefficient out front. So what I need to do is I'm going to move over the 1 first. So I'm going to say y plus 1 equals, let's leave the negative 3x squared, what is it, minus 12x. However, I can't create a perfect square trinomial until I pull out the coefficient out front. So I'm going to say, let's pull out the negative 3 out of both of these terms. I would get x squared plus 4x plus a blank. I take half of my b value and square it. But if you remember, the trick to when you have a coefficient is I didn't just put in 4. I put in 4 times negative 3. Okay, because if you distributed through, I actually put in negative 12. All right, so if I put in negative 12 on the left, I need to put in a negative 12. Excuse me, if I put the negative 12 on the right, I have to put it on the left. You have to balance your equation. Clean it up, you get y minus 11 equals, leave your negative 3 out front. If you factor your perfect square trinomial, you'll get x plus 2 quantity squared. And I would get negative 3, x plus 2 quantity squared, and then I'm going to add the 11. So my vertex would be opposite, so negative 2, positive 11. If I wanted to solve this equation, now that's in vertex form, I'm going to set it equal to 0. So I'm going to start out saying, okay, to solve, I'm going to set it equal to 0. I'm going to move the 11 over by subtracting it. If I'm isolating the x, I want to divide by negative 3 so I can get the x by itself. I have x plus 2 squared equals 11 thirds. Since it's x plus 2 quantity squared, I have to take the square root of each side. So I'm going to get x plus 2 equals plus or minus. Now, I actually can't do, if I do square root of 11, square root of 3, I don't know either one of those square roots. So I'm going to have to leave root 3. But what I need you guys to do then is rationalize this answer. So multiply top and bottom by root 3. Root 11 times root 3 is root 33. and then root 3 times 3 is 3. Okay, I'm going to solve for x by just subtracting 2 over, and that would be my solution. Okay, and again, you could graph this if we asked you to. Okay, I'm not going to do any more of the graphs, but just understand the connection of why we're getting it in vertex form and why we're solving is because if we put it in vertex form, I know straight away my vertex is negative 2, 11, and then negative 2 plus root 3 over 3 is going to be one solution. And I did do those, what I get? I got like x equals negative 3.91 and x equals negative 0.085. If you actually do those, you'll be able to see where the x-intercepts are and what my graph looks like without using a calculator to graph it anyways. And it should be a frowny because it's negative. So just trying to put together all the pieces of why we go from standard to vertex, why vertex form is helpful, and why solving vertex form is helpful. All right, so let's do 2 more with solving. If you think you can do 4 and 5 on your own, go ahead and try to do that. Go ahead and press pause in the video and just come back and check your answer. I don't need you to graph any of these. I just want you guys to go from standard form to vertex form and solve. So for number 4, again, first step is to get the constant over to the other side. So I'm going to say y, I don't know what you're doing, y minus 3. Excuse me, y plus 3, because I got added over, is equal to 2x squared plus 5x. But before I create the perfect square trinomial, I have to pull out this coefficient of 2. When I pull out the coefficient of 2, even though it's not going to be pretty, 2 divided by 2 just gives me x squared. 5 divided by 2 just gives me 5 halves. All right? I have to take half of that number. If you take half of 5 halves, it's going to give you 5 tenths. So that's my b over 2, is 5 tenths. All right? And when I have 5 tenths, sorry, not 5 tenths, 5 fourths. Hold on. Let's erase that. Okay, so 5 times 1 is 5, 2 times 2 is 4, so 5 fourths. If I square that so I can get my magic number, I'm going to get 25 over 16. Now, this is where it gets even more tricky. Oh my gosh. There you are. Sorry about that little break. I don't know what I just pressed on the laptop. So we need to put in 2 times 25 over 16. Since we put that in on the right side, I need to put whatever 2 times 25 over 16 is on the left side of my equation, and I need to add it to the left side. So again, you have to balance your equation. Whatever I put in on the right, I have to put on the left to make it balanced. So let's look at the left side. Working with fractions, the 2 over 1 would cancel with 16 and get 8. So I have 25 eighths plus y plus, if 3 is over 1, let's create and make that a common denominator of 8. So 8 times 3 is 24. I have a coefficient of 2. The number I got when I take my b over 2 was 5 fourths. I'm going to take that quantity squared. So again, this number is what's going to help me figure out what my ax plus b squared is. 25 plus 24 is going to give me 49 eighths. So 49 eighths plus y equals, keep the right side of your equation the same. And then if I solve for y, I'm just going to subtract over x plus 5 4 squared. I'm going to subtract over 49 eighths. All right. So my equation is now in vertex form. If I want to solve that, let's go ahead and start out by setting it equal to 0. So let's add 49 over 8 to the other side. Now, instead of dividing by 2, because I have a fraction, I'm going to multiply both sides by 1/2. Because that way I know I eliminate my 2, because I'm really dividing by 2. It's the same thing as multiplying by 1/2. But then it's a little easier for me to do this. I'm going to say it's 49 over 16. Now, since I have the quantity squared, take the square root. So I have x plus 5 fourths equals, The nice thing about this is that the square root of 4, I know I have plus or minus, the square root of 49 is 7, the square root of 16 is 4. So if I were to take 5 fourths over, it would be negative 5 fourths plus or minus 7 fourths. Okay, because those have the same denominator, I can actually put those together and get nice answers. So negative 5 plus 7 is 2. So 2 fourths would be 1/2. That'd be one solution. Negative 5 minus 7 over 4 would be negative 12 over 4, which is negative 3. So the crazy answer I got in vertex form, and the hard part to solving it, if you look back, I would actually be able to factor this, because if my solutions are integers, 1/2 and negative 3, I could factor number 4. All right, let's try number 5. Let's move the 1 over, and then we're going to pull out the negative 2 to make sure that I can complete the square. So y minus 1 equals negative 2. I'm going to pull it out of the first two terms. So negative 2 would be x squared. It would be minus 3x plus a blank. Half of negative 3 is negative 3 halves. I square it to get 9 fourths. I didn't just put in 9 fourths. I put in negative 2 times 9 fourths. So if I did it on the right side, I have to do it on the left side. Cancel the 2 and the 4, so I get negative 9 halves plus y minus, let's put this over 2, so minus 2 is equal to negative 2 parentheses x minus 3 halves quantity squared. I'm going to combine negative 9 halves and negative 2 halves to get negative 11 halves. I'm keeping the right side of my equation exactly the same, and then I'm just going to solve for y by adding over the 11 halves. So there's my problem in vertex form. If I wanted my vertex, it would be positive 3 halves and then positive 11 halves. Okay, so like 1 1/2 and 5 1/2. To solve this, I'm going to take my equation, I'm going to set it equal to 0 and go through the steps to isolate the x so I can solve for x. So let's minus 1/2. So move the furthest stuff away first. Again, instead of dividing by 2, let's multiply by negative 1/2, because that will cancel this to leave me with x minus 3 halves quantity squared, but then I just get 1/4. Okay, don't use decimals, use fractions. It's going to wind up being easier. Sorry, this is 11 halves, isn't it? I just wrote that wrong. So minus 11 halves, so that's going to be 11 fourths. Sorry, I just made the 11 a 1. So take the square root of both sides. I have x minus 3 halves equals plus or minus. I don't know the square root of 11, but I do know the square root of 4 is 2. So if I move this over, I have 3 halves plus or minus root 11 all over 2. And again, you could smush that together because they have the same denominator. All right, so those are some tricky problems from creating standard form to vertex form, and also an extension of how to solve them. All right, the last 3 problems are pretty easy, because when you go backwards, meaning when I go from vertex form to standard form, it is much simpler, because all I'm really doing is algebra. I'm foiling things out and just combining like terms. So if this is in vertex form, to get it in y equals ax squared plus bx plus c form, I'm just going to start by foiling, meaning I'm going to take x plus 3 times x plus 3. I'm going to do this first, and then I'm going to add 4. So don't do anything with this constant until the very last step. When I multiply through, I get x squared plus 3x plus 3x, so that's plus 6x plus 9. I bring down my plus 4, and the only thing I have to do is combine like terms. So it's x squared plus 6x plus 13. And I've just changed it from vertex to standard. So much easier to go backwards. Now, if you have a negative out front, just be careful you keep that negative. I'm going to FOIL x minus 2 times x minus 2. Again, the constant should be the last thing you deal with. So just leave this negative 3 and kind of bring it down. I have to make sure I leave my negative out front and FOIL everything in here. So x squared minus 2x is minus 4x plus 4. Because I'm going to have to take this negative, don't forget your minus 3, and distribute that throughout. So it's going to change the signs of everybody in my parentheses. Negative x squared plus 4x minus 4. Again, just keep bringing down that negative 3. At the very end, I can put those terms together to get negative x squared plus 4x minus 7. And again, I went from vertex form, and now I'm in standard form. right? Go ahead and try number 3, and the trick to number 3 is that you have a 2 out front. Do not distribute this first. You're doing order operation, so I'm doing parentheses and exponents first, meaning I need to leave the 2 alone. I'm going to have to do x minus 5 times x minus 5, and again, just kind of bring down that negative 8. Leave the 2 alone, FOIL what's in here, distribute first. I'm not adding until after I multiply, because multiplication is more important than addition. 2x squared minus 20x plus 50. I still have that minus 8. I'm only going to use that in the last step when I combine my constants. 2x squared minus 20x plus 42. And now I'm in standard form.